Hello, my name is Shlok Pandey and I will be presenting my ELL 101 project on ignition coils. So before understanding ignition coils, first we have to go over the basic working of an ICE. So ICE stands for an internal combustion engine, and ignition coil is like the heart of an ICE, and it is one of the most essential components required for its functioning. So an ICE consists of an crankshaft which is run through some pistons. Here in the diagram we can see four pistons running a crankshaft. So the oscillating pistons rotate the crankshaft, and these oscillating pistons are pushed down by an explosive combustion of fuel, and this explosion is ignited by the ignition coils. Now this ignition is achieved through a spark produced across the two uh, terminals of the spark plug, and these sparks are timed to perfection to ensure that the explosion takes place when the fuel is compressed to the maximum amount, so that the explosion is maximum extent, and also the different pistons explode at the coordinated time so that the crankshaft rotates in a continuous manner, and then the gear assembly and ultimately the wheel. So now coming to the main part of the project, which is how the ignition system of the IC actually works. So we need to produce some very high voltages across the two terminals to ionize the air between them and produce the spark. This involves some very fundamental concepts of electrical engineering, and let us go through what are these fundamental concepts. So there are many concepts, but these are the four main concepts involved. The first one is the setting up of magnetic flux in the coil. Second is stepping up the voltage from some small value to a very high value. Third is the inductive kick, which is the main part, which is where the spark is produced. And fourth is the precautionary handling of the back EMF using a condenser. So setting up of magnetic flux in the coil. The car battery runs a current through a coil, which is called the primary coil of the ignition coil. This primary coil generates some magnetic field around itself, and there is an iron core at the center of it, which magnetizes the iron core. And the secondary coil is also wound around the same iron core, and thus the flux is generated through both of the coils. And the car battery is the main source of energy to produce in producing these sparks, and the car battery is again then recharged through dynamos attached at the wheels. So the second part is stepping up the voltage. So as we will see in the next slide, the flux through the both of the coils changes rapidly. Thus there is a d phi by dt, which is the change of flux per some small change in time. And by Faraday's law, we already know that the EMF across any coil is minus d phi by dt, and the phi, which is the flux, is directly proportional to the number of turns in the coil. And as we can see in the diagram, the secondary winding has much more number of turns when compared to the primary winding. So the voltage across, if the voltage across the primary coil is something like 20 volts or 50 volts, it can be stepped up to something like 40,000 volts and 50,000 volts through the secondary coil. And the ratio of the EMFs between the secondary and primary coils is equal to N2 by N1, which is the ratio of the turns in the two coils. The flux is mainly through the magnetized iron core, and the flux through air is negligible in comparison to that. So now the production of spark in the spark plug. So the spark plug consists of two terminals. One is a terminal which is grounded, and the other terminal is connected to the secondary winding, which, as we have seen from the previous slide, generates huge amount of EMF. So the battery which is running the current through the primary coil is switched off. Due to this, the magnetic flux which is produced starts collapsing, and due to this collapse in magnetic flux, huge amount of EMF is generated in the secondary coil, which drives the current through it, and the voltage difference between the grounded electrode and the electrode connected to the primary coil is very high, and this is sufficient to ionize the air between them and conduct electricity through air, which is supposedly a bad conductor of electricity. And this spark is what ignites the fuel mixture, which is petroleum based or gasoline, creating the explosion needed. Now, what is the role of the condenser? So when the switch is opened and the flux start collapsing, we have seen what happens in the secondary coil, that it produces a spark. Similar to this, the EMF is also produced in the primary coil, although it is much smaller than the secondary coil. Yet this EMF is also sufficient to create some hazardous consequences. So the secondary coil, if there is no condenser, then the secondary coil drives the current back through the switch which was connecting it to the battery, and can even generate sparks across that switch. So to avoid this, a condenser is created, is used, which provides an alternate pathway for this back EMF current, and this current then charges the capacitor and uh, prevents it from going to the switch and creating some sparks. And if the condenser is not installed properly, it can lead to some very bad hazardous consequences, including burning of some other parts of the engine. So that is it. And ignition coils, as we have seen, is one of the most important devices in automobiles, and any vehicle which we see on road, almost all of them except for some electrical ones, all have this device, and it is very important. And we have also seen how it utilizes some of the most basic components of electrical engineering to create a very high voltage spark, to ignite the fuel mixture and create the explosion at appropriate firing times, and thus move the vehicle forward. Thank you.